The self-professed local guy, just ask him about St. Paul. He'll tell you how great it is. It gives me great pleasure to introduce to you Mr. Andy Brist.
Hello, hello. Today, we'll be talking about failover, high availability solutions. Who am I? I'm Andy Brist. I am support team manager for Nagios, all over the forums. I'm accessible through the ticket system. I'm also the team lead for Nagios Plugins. Spencer is the better half in the team, though I'd say he's the security guy. We can talk about plugins afterwards, but I assume we all are here for a different subject. I had this up before. It's really important to understand that there is no one size fits all when it comes to failover HA solutions. Everybody's got different requirements, different hardware, different problems with latency. Some people are in federated models, some people have geographic issues. The stuff I'm going to cover is from my case studies. I've implemented a lot of different types of failover solutions and hit a lot of the common problems that people see when they're trying to deploy this for Nagios XI environments. So my suggestions are my suggestions. Test in a lab first. Please, please, please test in a lab first. Nobody should be trying to deploy a failover solution without running it into the ground backwards and forwards a handful of times in a lab. Today we'll be just kind of covering short overview of some of the different types of solutions. We have a couple of fancy made-up terms, maybe. Jeremy gave me the idea to Failback, snapback, so we'll be covering some of that, and then we'll move into the failover solutions. We'll also talk about the XI data locations. I assume that's why most of you are here, is to actually figure out what in an XI system needs to be replicated in order to meet your SLA for failover solutions. And then at the end, we'll have some observation and considerations concerning like NDO, the databases in general, etc. First and foremost, backup. We'll call it snapback because you're technically losing historical data. This is the most common solution that people deploy. It's not a failover solution. It's at most a disaster recovery solution. It's usually restore the dang VM to an earlier point in time or spin up a new instance, bring the backup over. It's very, very easy. It also has the most potential downtime. It also leads to the most historical data loss. You could also lose configuration details that you've entered into your QL database, etc. And it usually takes manual intervention. It is scriptable, but at the point you're starting to script it, you're probably going to be moving into like a failback scenario where you actually have an automated failover solution. You're just losing data in the process of trying to recover from the disaster. XI does include an automated backup solution. It can use SSH, FTP, your local file system. We have a lot of clients that use this to actually try to automate some type of like failback solution. It's important to do the backups nonetheless, but I would not consider this an actual solution for failover. Like a typical failback situation is pretty straightforward. A handful of cron scripts. Usually your secondary is going to be checking your master. And then your primary will be pushing the backup tarball over, usually like SSH. And the restore job will run like once a day or like on the interval you specify. It'll restore the backup. This does mean that your passive and active agents need to be aware of two hosts. Well, your passive agents do. They need to be aware of two hosts, so you need to make sure that you have configured them. Your active agents do need to be aware of like a second allowed host. It's not typically the best solution, and if you try to grow the failover scenario horizontally, you have to then go into all your remote agents and like add new IPs, etc. As we just talked, it's periodically updated from a backup. Usually the process is started by hand. This can be automated. There is kind of a little race condition that can happen if you're in the middle of restoring data. When your failover needs to happen, you can't bring your databases up. The dump, or like the restore from the dump is happening. You might be still restoring your RDs. And so you start rolling out new RDs, and then the restore process fails because the RDs already exist, or they get overwritten, and then you lose more historical data. It's not a bad solution if you don't have an SLA concerning or PCI compliance concerning the data you need to actually preserve. If you just need to get another system up so notifications are going out, this is a solution, but I would not call it failover or highly available. Just kind of a note, it is different than the snapback solution or the image solution, because this is usually it's a different instance. You're not spinning up an older version of the same instance. Just a couple of points here. I think we covered most of these. Another thing to be aware of is SNMP traps also need to be configured to report to the second, third, or N hosts. You can have substantial downtime again if you're actually in the process of recovering when you need to fail over or fail back. Moving on to failover. Failover can be difficult to get right. It's important to test it. It can be demanding on I/O resources and how much latency you have, your overall network speed. Done correctly, you'll experience very little to no historical data loss, minimal downtime. This not only can be fully automated, it should be. And you can get some minimal clustering services to try to reach for that high availability prize that everybody wants. Kind of a typical situation. I did label this DRBD. Honestly, this can be any shared volume. I will be focusing quite a bit on DRBD in general because I feel like it's a pretty dang good solution given the whole Linux HA stack. You would package up all the shared files and your databases either on the shared volume or in some other type of replicated situation like MySQL. You can obviously offload and then put it into a replicated cluster. These management scripts, these can be pacemaker, ucart, keep alive D. They can be custom rolled scripts, but you need something to actually manage when the failover happens, who mounts up the shared volume. What's nice about these solutions is you get one virtual IP. And so all of your agents just report to that IP. That IP travels with the master. Now we're going to start talking about XI. There's a lot of things in XI that we need to take into consideration when we're trying to build a reliable failover system. We have the object configuration data, check status and object states, the program state. I mean, a lot of this comes from retention. And then your historical data sits in databases like RDs or the NDO database, and obviously your performance data. The services you need to be aware of, Nagios, MySQL, NDO 2DB, Postgres, MPCD, cron-d, and your Apache web server. Some of these can be clustered, some of them really shouldn't. They need to travel with the primary volume, and they shouldn't be fenced somewhere else. As far as the data and redundancy goes in XI, in any given scenario, the absolute minimum you need is a working object configuration in order to fail over cleanly. You need to make sure that the Nagios QL database is available. You could actually roll without it. You could just move the configs. Just don't, you have no way to access QL then on the XI box and change things. As soon as Nagios or as soon as apply configs run, it would eliminate those because they'd be ghosts. So you really need to make sure the QL database has been moved over, and the Nagios XI database, obviously. So you have users and you have all the necessary Postgres information for notifications, etc. To get full check redundancy, some additional requirements will be your MRTG config and the MRTG RDs. That's if you want to make sure that you're going to be receiving valid information about your bandwidth. And that's because MRTG needs to do the averaging and then roll it into the actual perf data RD. You need to make sure you move over or have replicated your libexec folder so that the plugins are available. And this includes any third-party SDKs. So that you need to make sure that your VMware SDK has been installed on both boxes. If you use the Oracle Perl library or Java JRE for certain types of JMX type checks. Runtime state redundancy. This is one of the last few pieces until we get the historical data. Retention.dat is actually really important. That's where your comments sit. That's where the runtime options are. Acknowledgements, notification depth. These are important things to make sure that you're failing over cleanly. Retention.dat should travel with it. A lot of people that set up these types of failover situations replicate the entire Nagios directory. There are some caveats doing that. We'll get to that in just a bit. You do need to make sure you also have the NDO MySQL database Nagios, so that when XI fires up, it's going to have the right states for all the objects in the UI. Historical redundancy, again, the NDO MySQL database, perf data RDs, again, MRTG config in RDs, or you won't be able to roll the averages into the perf data RDs, and then Nagios.log in the archives directory. So in this type of situation, again, you could just replicate the entire Nagios directory, or you could go ahead and move like the Nagios log location or like the archives folder through like a config setting and piecemeal symlink things to your shared volume. Yeah, I know I misspelled this here. It's okay. So just a quick summary. These are kind of like the general overarching things you need to be worried about when building a failover solution. And here are some direct paths. These are included just so that you can pull this up on the internet, the slides after the conference, so that you can remember the paths that are necessary to replicate in an XI environment. Most of this historical data, etc. I'm sure everybody here is aware of what all those things do. So high availability, Jeremy talked about it in depth. There's usually 3 things that are required. Elimination of single points of failure. You must have a reliable crossover. And you really want to detect failures as they occur. The Linux HA stack is really perfect for this. There is one issue with Nagios in general, and that's single points of failure. And there is no real good distributed model for running multiple Nagios processes on separate boxes. There are some hacks that exist out there, but for the most part, when you fail over, you need to move the Nagios process onto the failover box, and a lot of services need to travel with that. Why do you need it? Least amount of downtime. I assume you guys have a good idea why you need it, because that's why you're here. You can get limited service clustering. We'll move into that in just a little bit. And shared volumes are kind of the bread and butter of how you go about implementing and reaching your SLA in a failover environment. This is what actually kind of is the special sauce to making XI or any other application in your environment highly available. The major components: shared storage, a virtual IP, maybe multiple virtual IPs if you've offloaded SQL and you decided you're going to make it a DRBD cluster, or you're going to use the SQL clustering. You want to work off of virtual IPs. It makes it much simpler to move your services around. And your management application scripts like Pacemaker, etc. On to shared storage, DRBD. My good friend Jeremy, he covered this in depth. In my opinion, it's one of the better solutions out there, if not the best solution. It's part of the Linux kernel. You're going to find it on pretty much every major distro. It's well supported, well understood. It's good for pretty much all the different types of data that you need to replicate in an XI install. NFS can work. It's a fine option. There are some issues with latency. If your share can't keep up, your checks will get behind. And at a certain point, they might stack, and you're looking at restarting the process, clearing the queue. I wouldn't mount this volume to more than one server at a time. If for some reason it doesn't cleanly fail over, you might have multiple NDO processes trying to access the same database, etc. Or multiple checks trying to write to RDs, skewing your historical data. rsync, I don't think this is really technically a failover solution, but it definitely can work. There's a number of you I've talked to that do run rsync solutions for at least backups, if not preparing for failover. You can replicate the DBs. It's a really fine option. I would still look at using virtual IPs if you're going to do that. It just makes NDO and all the backend stuff that happens in XI easier. You only really get to define one IP in configuring PHP, so make sure that you've kind of covered your bases if you're going to spin up multiple database instances. On GlusterFS, we're not going to really talk about it. I did use it to offload MRTG and the RDs, and it was pretty slick, but the other solutions work just fine. DRBD, I suggest active passive. I do not suggest dual primary. We'll talk about why, but the major issue is what can happen with split brains, or what can happen when you have a Nagios process that for some reason you failed over incorrectly, and now you have multiple configs or multiple processes trying to write to the same volume. The nice thing with active passive is that when it fails over, only one box is going to mount the master shared volume at a time. The active mount should absolutely move with the virtual IP. That's pretty much like pacemaker and heartbeat's job. And again, for this section, you can really refer to my good friend Jeremy. He covered it in depth. For the virtual IP, you can use pacemaker. I did, worked fine. I also wrote some custom scripts that I then imported into the UCARP solution for virtual IPs. That worked fine as well. I did have some issues with Keep Alive D in Scentland. I didn't feel like it was very reliable. I don't know if anybody else out here has used Keep Alive D, but I noticed there was a number of times that it should have failed over, the virtual IP should have moved, and some reason Keep Alive D was not handling it correctly. That could just be my mistake in configuration, but I had better luck with UCARP, but I've been using UCARP for like 10 years, and it's old. I don't think it's been updated in half that. As far as failover management goes, again, we kind of just covered most of this. You can use Nagios itself. You can set up event handlers and have your second XI box literally just running like one check with everything else disabled. It gets really, really nasty to have to then turn all that on when it detects a failover. It's not very suggested. It's a better solution in core because there's a lot less things you have to worry about. And I mean, you could always set up cron jobs to do this, as we talked about in like the Failback solution. You could run a cron, run one of the plugins against the master box when it's not reachable, start firing off all the services to actually spin it back up. We're going to talk a little bit about STONITH and clustering. Embedded somewhere here in the clustering talk, we're going to talk a little bit about fencing too. Move on to just some extra kind of notes about DRBD, your shared storage. High latency HA with DRBD proxy, and what you're going to do about like recovering from a failure, recovering from your failover situation, and then we'll move a little bit into further disaster recovery. STONITH, I don't know how many people in here are aware of what STONITH is. I know Jeremy didn't talk about this. It literally stands for shoot the other node in the head. This is how you can manage, your servers can manage one another. If the master fails, you need to make sure it's dead. The secondary's now picked up the shared volume. It's considered master. It wants to make sure the master services are not going to get in the way. These are usually handled through hardware cards. You can use the SSH STONITH driver. I wouldn't necessarily suggest it. You really want your secondary, when it fails over to secondary, you want your secondary to shut off your master. And you really don't want to recover that automatically. You want to spin it up by hand, figure out what happened, and then add it back into the cluster, usually syncing it up to whatever's the new master. Be very careful when you're setting up scenarios in Pacemaker for what should fail over. Nagios does a lot of things. And in XI, there's a ton of services, and most service failures probably shouldn't cause a failure or a failover, especially if you've enabled STONITH, because you might end up with a deathmatch. You might actually end up in a situation where your servers kill each other until none of them are up anymore. So be aware of the types of scenarios you're willing to fail over on. We're going to move into some clustering and fencing and talking about which services can safely be failed over, which ones can't. Any actions, though, like this is a pretty good rule I found in my case studies. Any actions that require shared volume in active passive, they should not immediately cause the failover, because if there's latency involved in spinning up or mounting the shared volume on the secondary, it could technically bring itself back down, kill itself before it has a chance to mount the volume, because the services failed because the volume isn't there. And again, test. I'll probably say this 2 more times. This type of stuff should not be done in production. They should be tested in a lab, driven into the ground, and deployed with care. There are a number of services that can be clustered / offload. There are also a number of services that really need to travel with the primary mount, with the virtual IP. Those that can be clustered typically are almost better off being offloaded, and those types of services usually provide their own clustering. Postgres, MySQL. And yes, you can offload NDO to DB. You can set NDO mod to write to a TCP socket instead of a Unix socket. It's not documented now, but it will be next week. Spencer actually already wrote up the docs for it. We just haven't published it. You can also offload MRTG. I don't know how many of you stayed for Jeremy's talk and didn't listen to Brian Hayden's talk, but I know he was going to cover what it takes to offload MRTG. And in that situation, you probably want to look at some type of shared storage solution and a virtual IP. Services that are really dependent on the core monitoring engine that really shouldn't be failed over when they don't start or clustered would be Nagios, MPCD, your cron jobs, Apache, and the trap daemons. If Nagios doesn't start, is that a failover situation? I would argue no, because many times maybe someone makes a config change outside of the apply config snapshot process, and then they try to start the Nagios service or restart it. It fails due to config error. You don't want that failing over. If it fails over, it'll fail over to the next box, which will then try to spin up those configs, and Nagios will fail, and then it'll fail, and then you're back in the deathmatch. So definitely not that. MPCD really does need to travel with the checking engine. If you offload your RDs, your perf data RDs, you're welcome to do so. MPCD just needs to be able to find them through a symlink in the file system. If anybody's got a way to offload Apache from XI, let me know. I'd really, really like to know how that was pulled off, given the the very intimate nature, interconnected nature of the PHP scripts that Apache handles with direct access to the XI file system. If someone talk to me after, I really would like to know how to offload it if someone's been successful. Dual DRBD primary. I know Jeremy talked about this a little bit. I might disagree with him a little bit. I don't like it. I don't think it's safe. Not to mention all the things we talked about with why we have services that need to move with the active. It also can lead to things like split brains. And that's basically you have a failover situation. For some reason, it's not a clean failover. You have two boxes running, maybe handling a handful of checks each, and now you have two sources of truth. You're going to have to go in there and figure out which one is the real source of truth. It's much easier when in an active-passive mode, when the active fails, passive spins up. You know that new secondary is the source of truth. You can, in a recovery situation, you can spin up the old master, outside of the cluster, figure out what's wrong, and then resync its DRBD volume to the new master. Let's see here. There's some other issues with it. The secondary will lock the blocks. So if you're in a high latency situation, it's very bad. You can't, correct me if I'm wrong, Jeremy, but I don't believe you can set up dual primary with DRBD proxy. Is that correct? No. And for that reason, right? Yeah. Latency. More prone to split brains, we talked about that. And it usually requires clustered file systems, which can be a pain in the butt to set up if you're not running Red Hat. If you're running Cent, you're kind of in no man's land to actually get that set up correctly. High latency HA, these are usually problematic solutions. I would suggest you try not to use HA in high latency situations. You could potentially run into I/O wait issues, among other things. If it's not a hard requirement, you can go ahead and use like NRDP, outbound checks, passes, etc., to push them to another server, and then you can keep your HA solutions local. So if you have multiple, a federated model, you might want to, in the federated model, run failover, a pair of failover boxes in each geographic location, and then have all the checks pushed to a central server for reporting and maybe centralized notifications. DRBD proxy, we just touched on it. It is a decent solution if high latency is a must. It is asynchronous. It does push. You will run in. You can't use dual primary. So, as long as your network connection can keep up, you'll be okay. The failover solutions become a little bit more messy if you're doing a high volume of checks. There's also other issues with trying to fail over a WAN if the subnets are different, if routes are different. You need to make sure that you've taken care of those things in your environment. Some things I noticed with NDO in my case studies, I think this is important to make sure that you're enforcing a single NDO instance at any one time. Unclean failover situations could have multiple NDO processes trying to write to the NDO database. On face, it doesn't seem like a very bad thing until you realize that this might lead to some type of like expedited alerting if you're pulling stuff up, if you're pulling information out of the database and running your own event handler scripts with it. It could also lead to some other issues with your historical data. If you really need to have multiple NDO processes writing to the same database, use the instances. I don't know how well the instances are supported in XI at this time. I know there is a configuring PHP option. I did not run through all of the available services and checks to see how cleanly that instancing works. We do have a number of clients who do run an NDO database with multiple core instances, but they leave the localhost one primary instance for XI so that they don't have to mess around with configuring. Another good way to, this is why I like the VIP or the VIP solution, is you can use IP tables on the SQL server to make sure that the only IP that's allowed to write to the NDO database is the virtual IP for the cluster, for the XI cluster. And so when you fail over, only one of those boxes will have the VIP. And so it's a really clean way to make sure that NDO has been segregated correctly. You can configure NDO mod through TCP socket. If you want more information about that, just catch me afterwards. Spencer, I'll forward you the email. So just more issues with databases. I would never initiate a failover on crash tables. I would also be very careful about initiating a failover on the service not starting. You might have configured my CNF incorrectly. There's a number of other issues that you could have with tables that might get in the way of the service coming up. I would not suggest that is a failover scenario. You can offload both Postgres and MySQL. We don't have a document about Postgres. It works pretty much the same way. If you know how to dump and create the right user, you just edit what you need in configuring PHP. It should probably be a doc, I know. And XI has scripts to repair the databases. Use them. It's just a plug. Recovering from failover. Degraded X primaries, they shouldn't be added back to your cluster automatically. Always spin them up by hand, figure out what went wrong. Adding a degraded primary back to a cluster might lead to a split brain. It might also lead to a situation where you have a secondary that's in an unknown state and you can't fail to it cleanly. I would also suggest if you're running STONITH devices, have a primary image or an instance that's outside of the STONITH pool. If you do mess up in the configuration somewhere and the servers are literally shutting them off before you can get to a shell, it's nice to have another instance you can spin up that you don't need to drop into a single user, like mash an ion boot. So just something to be aware of. I would also suggest, if the SLA is really important, to maintain an ultimate disaster recovery box, something outside of the cluster, something that's probably a snap or a failback type solution instead of full failover. Something that you can spin up if there's a problem with the cluster. Just a quick plea. Failover, as Jeremy said, it's not a backup. Don't forget to back up. Please back up. Again, if you mess up in your cluster, you get a split brain, you try to fix it, you ruin the DRBD volume, it's nice to have some way to go back to, or you might end up at the unemployment office. Test in a lab. First, second, third, foremost, last. Make sure it works before you deploy it. And document everything. As a support technician, when I have to remote into a client's system and try to hunt down why things aren't working, I hate the gotchas. I hate the things, oh, we didn't change anything except for these three things. So especially in failover situations, document it all. Make sure that if you need to pull in a tech support agent, that they are aware of the type of environment you have before we start poking around and breaking more stuff than fixing. Just kind of some final comparisons we'll run over. Snapback, easy, slow, manual intervention, potential for high data loss. Failback, pretty easy to set up still. The recovery's a bit faster. It can be automated, less historical loss. It's all pretty straightforward. Failover, it can be difficult. It says difficult, it can be difficult. It can also be rather simple. If you just symlink all the necessary stuff into one shared volume, it's not that hard, especially if you have someone in-house who can handle writing the pacemaker scripts. And then high availability, or due to the single point of failure problem of Nagios, I don't think we can ever call it like 100% high availability. You can get pretty close. You can offload the services you can. You can pay special attention to what services need to travel with the monitoring engine. Take care of it through, make sure that you have your VIP solution set up correctly and that your agents are aware of it. It does also, introduce some other issues we talked about. Again, these are things like, STONITH death matches and split brains. These are things you can solve in the lab before you deploy. So please do so. And just kind of something here, I didn't touch on it. This gets really interesting. Federated models introduce all sorts of craziness to failover, especially with Nagios, because the clustering gets harder and harder the deeper down the federated model rabbit hole you go. If you're in a situation where you need this, and I know a couple of you do, catch me after or get me on the forums or pull me into an XI ticket and let's start talking about it. Bring one of your bang up awesome techs with, and we'll jump on the phone and do a conference call. Because I do want to iron how to do this out a little bit better than, which is the current model that I would say, which would be just a pair of failover boxes in each geographic location, pushing checks to a central box for reporting. This is kind of an old slide, but probably the most important thing is, if you don't have an SLA or requirement for it, is it worth your time? If all you need are notifications going out, you might have a different solution that makes more sense. Any good failover situation is going to cost you 3 times in hardware. It's just the way it is. So, is it worth the trade-off for the money you put into it and the time you put into it and the potential problems if it's not deployed correctly? Just something to think about. And that's about it. If you have any questions, feel free to ask away at this point.
For the virtual IP part, have you heard of people using a F5 appliance to handle the anything like that?
I have not heard of people using a load balancer to actually do. I assume that's what you're implying.
Yeah.
Yeah. No, it's not something I tested. I don't have a load balancer in house to do so, and I haven't talked to anybody that through the last 6 months that's trying to implement this. I'm sure people have solutions with it, but I haven't really dealt with anybody. I have dealt with a couple of people that are trying to deploy XI in an HA proxy environment, which I know isn't the same thing exactly, but they're able to do some work with it. Have you? Okay. If anybody has, speak up and let them know.
What are your comments about the distributed solutions like Mod German or DNX?
Because they're not failover or HA. Mod Gearman and DNX are distributed check solutions. That's kind of a different can of worms.
All right.
And you can, in a failover environment, deal with that cleanly. It's mostly dealing with the fact that your worker processes are all on boxes with IPs that you're aware of, and then you have to just make sure to fail over the Gearman process cleanly. That's actually a good call. I should have included that on the services slide. But it's not a failover solution. It's just a distributed check solution.
Okay.
Yeah, one other thing you didn't cover, which I've implemented, is the outbound transfers. So I've basically set up a DR box, import the backup every day or twice a day, and then I use outbound transfers from the prod into there. So I've got a pretty near real-time system that's running. I mean, it's not doing any active checks, but it's receiving all the data and all the graphs, and files are being updated.
I mean, technically, that's absolutely a valid way to go about it. You might run into a situation where you need to fail over, and the one thing you won't retain is your runtime state and potentially your object state.
Yes, you got to set them manually. Yep.
Yeah, and so it's definitely a shade of failover. Yeah. It's better than not having it, and it's cheap.
Yes.
It takes 2 pieces of hardware, and it's easier to set up, and it doesn't take a pacemaker guy in house to help you write a script.
Yep.
Other questions?
Softball, please.
Not a question for you, Andy. I'll go easy on you. Actually, just could we see a show of hands for people here in the audience who have currently deployed a successful HA solution for either Core or XI?
I think that counts. That does.
So about 2 or 3?
How many
Okay.
people here want to?
Okay. All right.
How many people here are going to go back and spin up a lab? Not enough hands. No, that's actually a good point. We're not HA guys. We're monitoring guys. Jeremy, Rust, and Linbit, they're HA guys. If you have issues with your HA deployment or you're looking for consulting on the HA side, the pacemaker side, or the DRBD side, or the associated network and hardware requirements, Jeremy and Linbit are the people to talk to. Like, we'll probably help you with the answers we can give you, but at a certain point, we might redirect you to them. They do offer support contracts, is that correct? Yeah, and their support's phenomenal. I mean, you even have a pacemaker guy in-house, a dev in-house. So I'll help you on the XI side as much as I can, as will the team, but if you run into some issues with the actual HA stack side, Linbit's the place to go to for help.
In light of all the recent hands that just went up, are there now questions for Andy? We have a meek and timid group.
They just want dinner.
Most people are going to be running a Nagios XI in a virtualized environment. And most of the hypervisors have the capability to HA in some sort of fashion.
Mm-hmm.
Have you ran into any issues where the hypervisor causes problems with the Nagios failover scenarios?
I've dialed into a couple of environments where they do just this, and honestly, no. It seems like, VMware HA is a solution. It's a decent one. It really is. In more complex federated models, it starts to break down a little bit. And that's because, for the most part, you have a lot of things to manage, and it seems to be a bit easier to use shared storage for that, and maybe piecemeal out your configs or instance out NDO. It's not like I'm not giving you the holy grail here. There are a lot of ways to skin this cat. There's a lot of ways to roll your own. Every environment kind of begs the question of what you need. So
I have 2 servers that I want to be HA.
Mm-hmm.
I keep them in sync, but I don't keep them completely in sync. There are some differences on the file system at the database level where they're basically changes where one server monitors the other, which maybe I don't want. But more importantly, other things that identify the system as being one system versus another system, so I don't always know what real system I'm on when I connect it to that, which means, of course, that I've got 2 almost the same systems, but not quite.
that's fine solution too. The more you enter into those types of rolled solutions, if you need to scale your failover horizontally, it just gets more and more complicated because all of a sudden you have 3 configurations on every server instead of 2 once you roll it out to 3 or 4 boxes, and it just grows. But it's a fine solution too. It'll work. And there's some nifty things you can actually do in those situations. The metrics you can pull are a little bit more direct. If you're gonna do like a DRBD solution and have full replication, you can still check the like what we call private IPs or whatever of the cluster boxes if you know what they are, or the host names.
Right. Because
So
I want
you
to
can-
keep the host name separate for when their email comes from, and I want to be able to go to the page and say, this is from this system versus
Yeah,
this
now,
system.
when you want to connect to the master, you connect to the VIP. When you want to connect to the instance or the actual object in the cluster, you just connect to its actual host name or IP address. They'll have both. Colosync needs some way to talk, or Heartbeat needs some way to talk between them. So, the VIP isn't the only way to reach them on the network. Any other questions? You can always catch me afterwards. I like Guinness, single malts.
All right, well, there you go. Once again, how about a nice round of applause for Andy Brist?